So this video is going to introduce the concept of inverse matrices to you guys today. I'm going to talk more in class tomorrow about why these inverse matrices are important and how they relate to a different kind of matrix called the identity matrix. So that's why this lesson up here at the top says matrix identities and inverses. But today I'm just going to focus on how do you find the inverse of a matrix. And if you're like, I have no idea what you're talking about, this is where you just go with it. Just, take it with a grain of salt. Trust me for a minute. I'm just going to show you the process, because I want you to know the process of how to do this, so that way when we talk about it more in depth tomorrow, you're not getting caught up on the process on how to do this, okay? So first things first, we're going to talk about how to find the inverse of a 2x2 matrix, and you are going to need to know the determinant, and that's something we've already talked about, is finding the determinant of a 2x2 matrix is you multiply these two numbers, subtract the multiplication of these two numbers from each other, okay? Then what you're going to do is if you remember, the determinant is also, you can write it as like that with like kind of like the absolute value bar signs. That number is going to go in the denominator right here. And then the other pieces of the inverse are going to be another matrix right here. Notice that the A and D values, they just swap spots right there. These ones on the diagonal. So those two swap spots. But the B and the C don't swap spots, but they do become negative, or they change signs, okay? So there's going to be a couple different pieces with it. You first need to calculate the determinant, and that'll go down here in the bottom of this. It always is 1 divided by the determinant, okay? Then that number will be multiplied with this matrix here, where these switch and these become negative, okay? And then we write inverse as A to the -1. That means the inverse matrix of matrix A, okay? I find it easiest to just work through examples of this, so I'm just going to go ahead and work through some examples. Thankfully, this formula is available on each page, okay? So another question here that's kind of asking is, does the matrix A have an inverse? So something I kind of forgot to mention, I apologize, on this previous page is what happens if you get a determinant of 0? It says right here that there's no inverse. And the reasoning why is, what happens if you have a 0 in a denominator here? That's not a good thing in math. We don't like that. So what we say here is that if the determinant is 0, then you would get a 0 here, which means that there is no inverse, okay? So that's why calculating the determinant first is always a great thing, because if it's 0, you're pretty much done, okay? So let's try this question. Does this matrix have an inverse, okay? First step, always calculate the determinant, okay? So the determinant of matrix A is going to be 3 times -3, which is -9, minus 6 times -1 is -6. Now remember, there's always a minus sign in between. This will become -9 plus 6 to give you -3. That number is not 0, so this does have an inverse. Yes, it has an inverse, okay? And since it does have an inverse, we need to now find it. Thankfully, here is the nice little formula here. I'm going to go and use that down here. The inverse is going to be 1 divided by the determinant. We just figured out the determinant on the previous step was -3, okay? Then we're going to have our matrix pieces here. And remember, we swap the spots of these two guys. So if -3 was up in the top, -3 is going to come down here to the bottom, and the +3 is going to go here. Those two numbers just did a switcheroo right there, okay? Then we're going to do, these ones are going to stay in their same spots. These two numbers are going to stay in their same spots, but they're just going to change signs, or both become negative of what they are. So this one will become -6 here, and this one will become +1. You don't have to write the +1 there. I'm not sure why I wrote positive, but I'll just put that there. Final step here is to do scalar multiplication. That's when you've got a matrix and a number being multiplied in front of it. Remember that that needs to be applied to every element in the matrix, okay? So we'll just simplify this a little further. We will make this 3 divided by -3, -6 divided by -3, 1 divided by -3, and -3 divided by -3. Remember how to multiply fractions? Okay? And then you've got 3 divided by 3 is 1, but there's a negative sign, so this will be -1. -6 divided by -3 is +2. 1 divided by -3 is just -1/3, and -3 divided by -3 is +1, okay? So here is your example of that would be your final answer right there. Boom. That is your inverse matrix, okay? So let's go ahead and try another example of that. Don't worry about this question right here. This is a question from your homework today. Find the matrix, inverse matrix, okay? First of all, let's find the determinant. We will go ahead and do 4 times 6 minus 10 times 2. This will be 24 minus 20, which equals 4. This will have an inverse because that's not equal to 0, okay? The inverse is 1 over the determinant, and you swap and make these other ones negative, okay? So we're going to have the inverse is going to be 1 divided by the determinant, which is 4. We're going to swap the diagonal pieces, 6 and 4, and then make the other ones negative or change their signs. And then we will simplify from there. We will make this 6 over 4, -10 over 4, -2 over 4, and 4 over 4, which 6 divided by 4 is the same thing as 3 divided by 2. -10 divided by 4 is -5 divided by 2. -2 over 4 is -1/2, and 4 over 4 is just 1. So there's your final answer. Boom. Okay. Let's do these ones. Now, remember, if our determinant is 0, no inverse actually exists. So this one, like I said, always your first step is check the determinant. Okay? What is it going to be? Well, it's going to be -9 times 2 minus -9 times 2. -9 times 2 is -18, and -18, subtract that, becomes -18 plus 18. That does equal 0. And if the determinant's 0, that means there is no inverse. We don't even have to keep going. We're all done. Ah, best day ever, okay? Then let's go ahead and do this one. -2 times 1 minus -6 times 1. -2 minus a -6 becomes -2 plus 6, gives us +4. Because that determinant is not 0, then yes, an inverse exists. Now, this question didn't require you to actually find out what the inverse is, just if one exists or not. Okay? We will do one more example, and then I'll walk you through, and then I'll show you what, I think I have two more examples that you could do. So I'll for sure walk through one more, and then we'll have 2 more that I'll show you on the page, so you could do them on your own if you want, and I can also maybe put the answers up. Okay? So first of all, find your determinant. That's always going to be your first step when you're finding your inverse, okay? You're going to do 2 times 8 minus -10 times -11. 2 times 8 is 16, minus 10 times 11 is 110. 16 minus 110 is equal to -94, okay? We'll go ahead and find the inverse by doing 1 divided by the determinant. Over here, we got it as -94. Boop. Okay. Then we will swap the pieces on the diagonal. So swap the 2 and the 8. So the 8 will come up here, the 2 will come down here. And then we will make this 10 positive and this 11 positive. We will just change their signs, okay? Last step here is to distribute or multiply this -1 over 94 through. So this will become -8 over 94, -10 over 94, -11 over 94, and -2 over 94. This will become -4 divided by 47. This will become -5 over 47, -11 over 94, and -1 over 47. Okay, not gonna lie, that one was kind of gross. I sincerely apologize. But there you go. That would be your final answer. And I'm sorry that that one turned into a gross fraction. Okay? Here is the next two questions. Okay? Find the inverse if it exists from your homework today. Give you a minute to pause it, and you can write it down. And then here's the other one, also from your homework. If you want to just go ahead and get started on it, go for it. But I will post the answers here in this video here in just one moment. All right, here's the answer for number 11. It does give you fractions in your matrix, but it's not as bad as the last one we just did. And here is the answer for number 14, also with fractions, but not as bad, okay? So I hope that this was informative. Since this is very procedural and algorithmic of a process, I was hoping that just running through this type of material at home on your own would be helpful. And then tomorrow in class, we're actually going to dive into why these things are important and to kind of help lay that foundation, okay? All right, have a good night. Keep working on your homework, and I'll see you tomorrow.